last week. So as I mentioned last week, that to do areas, volumes, and perimeters and whatnot properly, it's very important that you know Pythagoras theorem, definitely, right? Algebra and cross multiplication. It's also important that you know sine, tan, and cosine, but I know I only assigned the sine, tan, and homework last week. So all the questions, I'm going to try to leave out the sine, tan, and cosine component, but I will be focusing on the remaining stuff. So let's get started. So this was one of the questions we saw last week. This here is a semicircle, but better known as a half of a circle. So let's do an easy question first, right? Feel free to turn back in your notes, right? It's always a good idea to have your notes from last week, present in this class. So we're going to start off with, let's assume that the radius of this semicircle is 19 centimeters. The first thing I want you to do is find the area. Very, very simple question. Remember, a semicircle is just half of a full circle. So everyone, quickly send the answer for this one on the chat here. Now remember, the area of a full circle is pi multiplied by radius squared. So last week we wrote the question just like this. The formula, sorry. Pi multiplied by the radius squared. But this is the area of a full circle. And I think a lot of people are forgetting the square. Like literally half the class forgot the square. So the area of a full circle is pi r squared. But this is not a full circle. This is half of a circle. So we have to divide everything by 2 afterwards. Now, last week I showed you how to summarize this, right? I don't want to repeat the whole thing from last week, right? I'll be wasting time. This r squared, it actually belongs on top with what? The 22. So it's 22 multiplied by r squared divided by 7, and then we divide by 2. And last week I showed you a shortcut. How you dividing this by 2? This 2 actually gets multiplied by the denominator on top. So if you look back in your notes, you could have seen that the area of a semicircle could have been simplified to 22 multiplied by radius squared divided by 14. How much of you all can physically turn back and see that formula for the area of a semicircle? Make sure you can see it in your notes, right? Right, so look back, make sure you see it. So all we have to do now is use this formula to find the area of the semicircle. So let's substitute in some values here. It's 22 multiplied by the radius squared, and the radius is 19. So it's 19 squared. And then whatever you get, you divide it by 14 afterwards, right? So it's 22 multiplied by 19, press the squared button on the calculator and divided by 14. And you should be seeing something very, very close to this. 567.2. If you round it off properly, you will get 567.29, and well, it's area, so it's centimeters what? Squared. Now, I'm not going to fight about the 2 decimal places, but once you have the whole number part, let's take it as correct today, because some calculators will give you the answer in decimals, and some calculators, depending on the brand of calculator, will give you the answer as a fraction, right? All right. So for those who got it wrong, you think you saw your mistakes? Let me know, because a lot of people did get it. So the area of a semicircle, where I guess you all can memorize this now, right? So the area, and I'm drawing the shape here of a semicircle, I guess you can memorize it as 22 multiplied by radius squared divided by 14. So fine. So let's say the question came the opposite way now. Let's say that the examiner told you that the area of the semicircle, which is half of a circle, is 40, let's put a 49 centimeters squared. And they are asking you to find the radius. So they don't know the radius, so I'll put an R and a question mark. Using the same exact method as last week, could you all find the radius of the semicircle? I'll give you a hint. You would end up cross-multiplying. This is really a cross-multiplying question in disguise. If you decide to use this formula as your normal formula to find the area of half of a circle. Good luck. Send the answers across. This one. So this question is just a substitution question. Let's see. They gave you the area of the semicircle this time. So the area of the semicircle is 49. They came out right. And the area of a semicircle is 22 multiplied by the radius squared, right? Divided by 14. We want to solve for Mr. R, which is the radius. Now, 49 is the same thing as 49 divided by 1. So now we have a fraction on both sides. So we have an excuse to cross multiply. Let's cross multiply this diagonal first because it has the letter R, the letter that we are trying to find. Anything multiplied by 1 is itself. 49 multiplied by 14 is 686. Remember, we're trying to solve for R, so keep your eyes on the R. The 22 is a multiply. Throw it across, we get what? A divide. So now we have R squared is equal to 686 divided by 22. We get in 31.18 or something like that, something very close to that. Throw across the squared because we want to solve for R. The opposite of a squared is a square root. And if we square root second function, I have to press second function on my calculator, 31.18 is 5.58 or something like that, or something very, very close to that. I'm not too sure why so many people got 7 point something, but the correct answer seems to be 5.58. Look for your mistakes. Let me know if you spot it, right? Jaden, you saw your mistake? Good. So in this particular question, they ask you to find what? The radius, right? And we got the radius to be 5.58. Sometimes the examiner will be a little sneaky, sometimes, and they will ask you to find the diameter. I spelled diameter wrong there, but let me start back. Diameter. How much is the diameter if I were to ask you that question now? Let's say the first question was worth 3 marks. And then after they ask you this question, they ask you to find the diameter for 1 mark. Anybody wants to help me answer that question? How much would the diameter of that semicircle be if you just found the radius? Right, and everybody is telling me, well, a lot of people are telling me, all you have to do is take the radius, which is 5.58, and multiply it by 2, because the diameter is always twice the radius, always twice the radius. So 5.58 multiplied by 2, we're going to get 11.16 centimeters. Right, so look out for those little sneaky questions in the exam, right? They might ask you to find radius and then ask you afterwards to find the diameter. So this kind of, for the time being, concludes a little revision on how to find the area or radius of a semicircle. But what about perimeter? Remember, the perimeter is the distance around the shape. You have to pretend you're running around the shape. Just to refresh your memory, for a full circle, to find the circumference, if you look back in your notes, right? To find the circumference of a circle is pi multiplied by what? The diameter. But we all know the D belongs on top with the 22, right? So this is the formula to find the circumference of a full circle. Let's see if I can trick you now, right? If you have a semicircle, remember, semicircle is half of a circle. Let's say the radius of this semicircle, let's call it 14 centimeters. Here's the question, and it's a trick question, so don't do it too fast. Find the perimeter of the semicircle or of that shape in front of you. Find the perimeter. Try this question and send the answer on the chat. It's a slight trick question. And the examiner loves to pull this trick on you in the exam. So the area of the circumference of a full circle is that formula in front of you right now, the 22/7 multiplied by diameter. But I want to find, remember, this is half of a circle. So a lot of people, what they will do, they will take this and divide it by what? 2. And that makes sense, right? So let's go ahead and try this. Let's see what this formula will give us. So we have 22, right, over 7 multiplied by the diameter. Now, the diameter is how much? The diameter is not 14. Remember, the diameter is twice the radius. So if the radius is 14, that means the diameter is 28. So this will give you the circumference of a full circle, but then we have to divide it by 2 because it's what? A semicircle. So everyone work this part out only for me and tell me what you get. Work out the top part first and then divide it by 2 straight on the calculator. You can do that straight on the calculator. And what will you get? 22 multiplied by 28 divided by 7. That will give me 88. And then I divide it by 2. Are you all seeing 44 on your calculator? A lot of people are saying, yes, they got 44 for that part. The problem is a lot of people stopped there. They thought that that was the final answer. Tell me something, that 14, right? Let me get a thicker marker here. Let me get a little bit of a different color. Let me get orange. That 44 is from here all the way to here, right? Half of the circle. So that's 44. But tell me something. If you are running around the shape from here all the way to here, that orange part is 44, but isn't the perimeter? If you start at point A, you have to run the curve distance, which is 44 centimeters, all the way to B. But that's only the curve part. And to run back to A, you have to run back here, and then you have to run back here. So you run from A to B, that's 44. From B to the center is how much? This is like a windshield wiper. If you pull this down, and over here will be 14, and over here will be another 14. So how much is the total perimeter? It's 44 plus 14 plus another 14. I get in 72 centimeters, right? So when you take this formula and you divide it by 2, that only gives you the half of the curved portion. This one has an extra piece to run, right? Okay, you're running from A to B and then back to A. For those who got it wrong, you think you saw your mistake? This is a popular question that teachers like when they go for your end of term exam and you did areas and perimeters and whatnot during the term. The same question will pop up, I bet you. Right. So here we have a different shape now. This is piece of a circle. It's a pizza slice. This is called a sector, right? So we're on sectors now. In a sector, well, we all know if you had a full circle like a pizza, and here was the center, this dot. if you take a slice of pizza, so let's say this is a pepperoni and whatnot here, right? Pepperoni and mushrooms. A slice of pizza is a sector. So usually here's the center of the circle, right? And the sector will start at a point A and usually end at a different letter. Most people will call it A and what? B. From the center to point A or from the center to point B is your radius. They usually use the letter R as usual for that. All sectors must have an angle in between the two radii. They usually call that angle theta. And he would be like 20 degrees, 30 degrees, 40 degrees, who knows, right? So how do you find the area of a sector? Well, to find the area of a sector, you have to take pi, right? Which is 22 over 7, right? Multiplied by the radius squared, multiplied by the angle, right? And then you always divide it by, well, actually the better way to do this, because this will confuse you all, right? That's that one. Let me write this formula a little bit different, right? You have to multiply by the angle, and you always divide the angle by 360 degrees. That's the formula for it, right? Now, this can get a little bit, how you say, because we're using pi as 22 over 7, right? Remember, the 22, the r squared, and the theta are on top. The 7 and the 36 are underneath. So you can rewrite it like this. 22 multiplied by radius squared, multiplied by the angle, and what is it divided by? 7 multiplied by 360, right? So this is a formula you could use to make your life a little bit easier. And don't worry, they give you this formula for those who are doing CXT exams. They give you this formula on the formula sheet, but it doesn't look like this. This 22 over 7, they just replace it with pi. So it will look like this. Pi multiplied by radius squared multiplied by theta divided by 360. But pi is really 22 over 7, right? For those who are in Form 2 or Form 3, your teacher not going to give you the formula. You have to memorize the formula for the exam. All right, so everyone, let's try a quick question for me. If the radius of this sector, right? Let's say the radius of this sector is, let's erase this here. Let it be 25 centimeters and let the angle be 60 degrees. Calculate the area of that sector for me, right? I would prefer if you use this formula here, the one in the middle. Right. Right. I want to point out something that may be obvious already with regards to the formula. You'll realize that the area of a sector is basically the area of a full circle. What I'm circling here, isn't this the area of a full circle? Pi multiplied by radius squared. To find the area of a sector, you just take the area of a full circle and you multiply by the angle divided by 360. That's the only additional piece to the formula, right? So this 22 over 7r squared is what? The area of a circle multiplied by the angle divided by 360. So anyway, let's go ahead. 22 multiplied by the a lot of people are forgetting to square the radius. The radius is 27. So it's, sorry, 25. So it's 25 squared. How much is the angle? The angle is 60 degrees. And we have to divide it by 7 multiplied by 360. Now, you might have to work this out in two parts, right? Work out the top, write down the answer, work out the underneath, write down the answer, and then divide. I would prefer if you work it out in parts, and don't try to be a hero and type in the whole thing straight on the calculator. I think you're prone to making mistakes if you type in the whole thing straight on the calculator. For the top, right, I'm getting 8, 2, 5 with 3 zeros. and 7 multiplied by 360, I'm getting 2520. So you just have to divide that, right? Let's divide it, right? 825000 divided by 2520. Yeah, most people got it correct. 327.38 centimeters squared. Right now, if you're really good with your calculator, I guess you can type in the whole thing straight on your calculator. But for those who don't have the confidence to do that, work out the top, write down the answer. Work out the underneath, write down the answer, and then divide. For those who got it wrong, you think you understand your mistake? I think the most popular mistake is the squared, that 25 squared. People are forgetting to press the squared button. Right, so let's try one more for me. Let me just make sure everyone gets this before we move on to a slightly different question. Let's say that the radius was 40, let's call it 4 centimeters. I'll make up an easy number. And let this be 79 degrees. Find the area of that sector. So it's 22 multiplied by the radius squared. This time the radius is 4, so it's 4 squared. The angle is 79 degrees. It doesn't matter if it's an odd angle. And underneath is 7 multiplied by 360. Right? So 22 multiplied by 4 squared. Right? For the top, I'm getting 27808. And for the underneath, 7 by 360. Well, that will always give you what? 2520. Divide both of them. And I'm getting 11.03 centimeters squared. Right? That's a 0 there, right? 0.3. All right. So let's try a slightly different formula now. So this was to find the area of a sector. The curved distance of a sector, the curved distance, I'm talking about from A all the way to B, only the curved part. You call that part of the sector the arc. The arc is just the curved part. To find the length of the arc, right? Or you could just call it arc length, right? It's almost the same formula, but instead of radius squared, you have to put diameter. So this formula comes like the circumference of a full circle, and then you multiply it by pi divided by 360. So you see the slight difference in the formulas. The last one was radius squared. Diameter is different from radius squared. So put the diameter here. So just write down the new formula now. And for this question, I want you to find the length of the arc. Let me give you some different values. Now remember, the formula calls for the diameter. I am giving you the radius. Let's say the radius is 8 centimeters and the angle, let's call it 45 degrees. Find the length of the arc, which is only the curved part. All right, so we have 22 multiplied by the diameter. The diameter, we have to multiply him by 2, so the diameter will be 16. The angle is 45 degrees, and we divide it by 7 multiplied by 360. Now, we know the underneath part is always going to be the same. 7 by 360 is 2520. 7 by 360 will always give us that. The top is 22 by 16 by 45. 15840. Let's divide. 6.2, if you round it off properly, 9 centimeters. So the curved part is 6.29. Quick question. Is that 6.29, is that also the perimeter of the shape? Like that 6.29 that we just found, could that also be considered to be the perimeter? The answer is no. But could you all find the perimeter for me now, just in case the examiner asks you to do that? Could you all find the perimeter for me? Pretend you're running around the shape. You run from A to B, you know that curve distance. And then from B, you have to run to O, and then run back to the starting line, which is A. What to do? You have to take this 6.29 and add 8 and another 8. So you're adding 8 twice, right? And when you do that, you're going to get 22.29 centimeters. Right, so take a 20 seconds, take down what you need to take down, and we're going to move on. When you're finding the area or length of an arc, right? This formula or the one that just before, you all notice where the angle is, right? The angle is inside the sector. That 45 degrees lives inside the sector. You all are probably asking, but where else could the angle be? Obviously, the angle has to be inside the sector, not all the time. And you're going to eventually see a question like that, where the angle is not inside of the sector. The examiner will trick you and place the angle somewhere else. But it will only work if the angle is inside of the sector. So let's move on. Right, so this is my trick question. Is this green part of the pizza, is that a sector? The green part, the green portion here, is that considered to be a sector? Yes or no? Not the part that missing it. I'm talking about the part that existing, the green part. Okay. Let me put it like this. This slice of pizza is a sector, right? Remember, a slice of pizza is a sector. So yes, this one here is a sector. If the slice of pizza got bigger, like somebody who was sometimes when people come to take a slice of pizza, they look for the biggest slice. This is also a sector. If someone were to take half the pizza, that would also be a sector. And if somebody were to take a huge part of the pizza, it is still a sector. This green thing here is a slice of pizza, just a very huge slice of pizza. So yes, it is a sector. So here's what I want you guys to do. I want you to find the area of this sector. We're going to do two things. We'll find the area and then we'll find the perimeter. Let's say the radius is, I don't think y'all can see that color too good. I'm going to get yellow. Let's say the radius of this sector is 20 centimeters. That's a good size pizza. And let's say the angle is that looking like what, 42 degrees. Find the area of that, of the green portion, of the existing portion. Good luck and send the answer on the chat. So let's substitute in the values in this formula. We have the 22. The radius is 20. So radius is 20 squared. So we have 7 multiplied by 360 underneath. But the angle, is the angle 42 or am I trying to trick you? The angle is not, if you put 42 for the angle, you're going to get it wrong, right? And this was the major trick of the question. Remember I said, when you're trying to find the area of a sector, or you're dealing with sectors, if they give you an angle, the angle has to be inside, right? The angle has to be inside the sector. Is this 42 inside the sector or outside? Here's what? Outside the sector. Isn't the inside angle this yellow angle here? Isn't the yellow angle the one that lives inside of the sector? But I didn't directly give you the yellow angle. But don't we know that a circle is 360 degrees? We know this. So if a full circle is 360 and this portion is 42, how much is the yellow portion? It's a subtraction question there, right? So what's the angle inside the sector? Isn't it 360 degrees minus 42 degrees, which is 318 degrees? So the angle you're supposed to do is 318. For those who did it wrong, you think you could quickly do back the calculation and send it for me? By now, everyone should be able to type in the top, write down the answer, and divide by the underneath. Send the answer quickly, and let me see what you get. All right. This question is also very popular in the exam and amongst teachers for term tests, right? Getting it? The final answer when you work out this on your calculator is 1110.48 centimeters squared. So we're going to adjust this question to find the perimeter. Now, to find the perimeter, if the examiner were to ask you that, right? But what you will need to do is find the length of the curved part. Let me get a different color here, red. You will need to find the length of the curved part. Now, the curved part, as I mentioned, is called your arc. Arcs could be big, arcs could be what? Small. This is a huge arc. So to find the length of the arc or the arc length, right? You have to adjust the formula. It's no longer the radius squared. You have to adjust it to put what? The diameter. So let's redo this question now. The diameter would be 40 because if the radius is 20, that means the diameter is twice the radius, which is 40. And we know the angle is 318. So we're not falling for that trick again. 22 by 40 divided by 3, multiplied by 318, divided by 7, multiplied by 36. Anybody was getting this? For the curved part only, 111.05 centimeters. So the curved part was 111.0 how much? 5 centimeters. But I'm asking you to find the perimeter. So when you run from A all the way to B, you still have to run from B to the center and then from the center to A. So you run 20 plus another 20. So you have to add an extra how much? 40. And that brings my total to 151.05 centimeters, which is what a lot of people sent. Look for your mistakes. Let me know if you saw your mistake, and we will move on. Let's move on. Right. So this I was gonna do more sectors question, but I think we got the general gist of all the little tricks and whatnot there. Let's try a compound shape now. A compound shape is where two shapes are mixed into one shape. The first thing we want to do, we're going to try to find the area of this shape. So let me give you some values. I'm going to call here A, and I'm going to call here B. And let the distance from A to B be 20 centimeters. And let here be C, and I'll just call here D. From C to B, let the distance be 30 centimeters. Find the area of that shape. I know some of you might think that I forgot a measurement, but I didn't forget anything. You have everything in front of you there now to find the area of that compound shape. Look at it. It's really two shapes merged into one. Find the area of each shape and then add them. Good luck. So at the end of the day, we're finding the area, right? And it's two shapes mixed into one here. You can clearly see a rectangle. So this guy here is your rectangle. And the one on top is your semicircle. To find the area of a semicircle, remember it's 22 multiplied by radius squared. And if you use the formula we used this week and last week, you can put 14, right? You can look back in the notes. That's how you find the area of half of a circle. And the area of a rectangle is length by what? Breadth. Right, so how much people use those two formulas at some point in their calculations? I know for the top one, some people might just find the area of a full circle and then just divide it by 2. That will obviously work as well. Right. So let's do the rectangle first. That's the easier one. The length is what? The length is 30 and the breadth is 20, right? It doesn't even matter if you mix it up, right? If you call this one the length and this one the breadth, it really doesn't matter. Just for the rectangle, call one the length, one the breadth, and you're good to go. So 20 by 30 or 30 by 20 doesn't really matter. You're going to get 600 centimeters squared, right? Everyone is supposed to get that one correct, right? For the one on top, the semicircle, I didn't really give you the radius. But if from A to B is 20, from D to C is also 20, the opposite sides of a rectangle are equal. Now, quick question. This 20 from D to C, is that the radius or is that the diameter of the semicircle? Is that the diameter or is that the radius? That's the diameter, correct, guys. Remember, my formula, well, this formula that I'm using requires the radius. So if the diameter is 20, then the radius has to be half of that, 10. So it's 22 multiplied by 10 squared divided by what? 14. 22 multiplied by 10 squared divided by 14 is 157.14 centimeters squared. To get the full area, we just have to add them. So you add these two values, you're going to get what? 757.14 centimeters what? Squared. Look for your mistakes. Look for your mistakes and let me know on the chat. Right? Right. So I want to go about this question two ways, right? For part A, right? 'Cause different people, how you say, will look at this question two ways. If I ask you to find the area of this shape of part A, one way of doing it, right? Okay, one way of doing it is to split this into two shapes. So just like how you would have done it in primary school, right? So you could split this shape this way, or obviously you could split it this way if you wish. So you call this part A and you call this what? Part B. Remember, we're trying to find the area here, not perimeter, area. So all we have to do is find the area of part A and the area of part B, and you do what with your answers? Add it. It's in you can handle this. This is just a primary school question, right? And believe me, it does come back in CXC, and of course, it will come in Form 2 and Form 3 as well. Find the area of shape A and B and add your two answers. And let me know what you got, right? So it's two rectangles. Now, for rectangle A, it's just length by breadth. So for part A, it's just length by breadth, which is just what? 6 by 4, which is 24 centimeters squared. For rectangle B, right? Let me just, so you can focus on it. Let me put it in red. We know one measurement is 5 centimeters, but how much is from here to here? Let's call it M and N. What's the length from M to N? They didn't directly give you, right? But it's supposed to be 4 centimeters, right? Because if from here to here is 6, then from here to here is also 6. This portion is 2. So if the whole thing is 6, and here is 2, then the balance would be 4. And the opposite sides would have the same exact what? Length, right? So for B is length by breadth, right? Which is 5 by 4, which is 20 centimeters squared. So you add both of them and you all got 44 centimeters squared. So that's one way of doing that question. Now, if I go to another set of students, right? You know that they might see this differently. They will see this question much different. They will not see this as two shapes in one another. They will not see shape A and shape B. Let me show you what they might see instead. And you're going to get the same answer. Clearing everything, right? That's clearing everything off. What they will see is this. They will see a rectangle, a full rectangle like this. Let me complete this. If this was a full rectangle, right? I just say like this piece wasn't missing. Let me say it was a full rectangle. Here would be 6. Anybody want to tell me what the distance from here to here would be? I'll call here A and I'll call here B. What would be the distance from A to B? Nah, it's not 8 centimeters. Somebody had it wrong. Nah, check it back, check it back. Won't it be 9 centimeters? If from here to here is 5, any opposite sides of a rectangle are equal? So that means here would be 5. So 5 plus 4 would give me 9 centimeters. So if this side is 9, then this side is also what? 9, right? Everyone is okay with that, right? Great. So what would be the area of the full rectangle? The area of the full rectangle would be what? Length by breadth. So 9 by 6 is how much? 9 by 6 is 54 centimeters squared. But we know that's not the answer we had last time. The last answer was 44, right? So it come like you had a full rectangle and then a rat came and eat piece of the rectangle. So he stole part of the rectangle. What's the area of the stolen part? The stolen part is also a rectangle. The stolen part is 5 by 2, length by breadth. 5 by 2 is what? 10 centimeters squared. So what if you had 54 and somebody stole 10 or eat 10? That is a minus question now. 54 minus 10 will give us the 44 centimeters squared. Which one do you all think is easier? Because like I said, different people are going to see this question slightly different ways when finding the area. Do you think it's easier to split it into two shapes and add, or pretend the whole shape was there in the first place and then someone stole piece? And it have no right or wrong answer for this. Which one is easier for you? Split it into two shapes or pretend it was a whole shape in the first place? Let me know in the chat. Let's look at the second question, right? Let's look at the second question. In the second question, there are two ways to go about this question. We could split this into 3 shapes, 3 rectangles, A, B, and C. I think that would be a lot of work. Won't it be easier for us to pretend that this was a whole shape in the first place? Like this was a whole shape and then a rat came and stole piece? In this particular case, the second method would definitely save time in the exam. Could you all find the area of this shape using the whole shape and then subtracting the missing piece afterwards? Right? And send the answer on the chat. Let's pretend that this was a whole shape first. So no rat came along as yet. It was a nice rectangular biscuit. So if it was a full rectangle, length by breadth would be 12 by 6, which is 72 centimeters squared. Let me double check that. 12, I'm not good with 6 timetables. Right. Then a rat came and ate this portion. And this is also a rectangle, length by breadth, 3 by 2, which is 6. So we just have to minus 6 from it. 72 minus 6 is 66 centimeters squared. Right? A lot of people sent that answer, so that's good. Take a 20 seconds, take down what you need to take down. All right. So we're gonna try some stuff with triangles now. We're gonna start off with the easiest triangle. Some stuff that I mentioned previously when we were doing Pythagoras theorem. When you have a right angle triangle, that's a triangle with a right angle. Remember the side opposite the right angle is called your hypotenuse. And the hypotenuse is never a base or a height. The two other sides, other than the hypotenuse, are just called legs. So a right angle triangle has two legs, and both legs always touch the right angle. And the one who is not touching the right angle, who's opposite the right angle, is always the hypotenuse. Never ever assume the hypotenuse is a base or vertical height. Only legs could be a base or vertical height, right? So everyone take down this note here. It's the same thing that I just said. And it's going to come back to this formula. The area of a triangle is base multiplied by the vertical height divided by 2, right? Just remember the base, the hypotenuse is usually never a base or a vertical height. And then we'll try a few questions on this. All right, so let's move on there. Right, so here we have a right angle triangle. Let's say here is 6 centimeters, and here is 10 centimeters. I want you to do two things. You have to find the area of this triangle and also the perimeter of this triangle. You have two jobs. Send the answers across. Now, if you're sending the answer for area, make sure and say area, or you can just say A is equal to your answer. And if it's perimeter, say perimeter, or P is equal to so and so answer. So I don't mix it up. All right. So the area, right, is, well, remember, the side opposite the right angle is the hypotenuse. I'll put HYP. The base and the vertical height always touch the right angle. So the area of the first formula you usually learn for a triangle is base by vertical height. I put VH for vertical height divided by 2. So it really doesn't matter if you mix up, like if you call him the base and him the vertical height, or you reverse it. So I'm going to call the 6 the base. The vertical height is 10, and then you divide it by 2. We can do this in our head, right? 6 by 10 is 60 divided by 2 is 30. So it's 30 centimeters what? Squared. So this is an easy question. However, the second part asks you to find the perimeter. Now, the perimeter is the distance around the shape. So let's call here A. Let's call this one B, and the other corner C. So we're gonna walk from A to B, B to C, and then C back to A. Now, the good news is we have the length from A to B, that's 10. We have the length from A to C, that's 6 centimeters, but we don't have the length from B to C. But couldn't we use Pythagoras theorem to easily find the missing side of a right angle triangle, right? Which formula would you use? The one on top or the one underneath? Which one is the correct? Everyone should be able to get this one correct by now. Which is the correct version? BC, ask yourself. BC is what part of the right angle triangle? Is it a regular boring side, a leg, or is it a hypotenuse? It's the top one. It's the hypotenuse, okay? So it's the top one. So you have to take the length of the two sides, 10 squared plus 6 squared, and then you square root the answer, but square root last. That's your best way to get it correct. 10 squared plus 6 squared is 136, and then you have to square root it. And when we square root it, we're going to get 11.66 centimeters. So now we have the missing side, 11.66. Add up all three, and well, you have your perimeter. I'm getting 27.66, but confirm it, centimeters. Some people are saying it's wrong. That's now 10 plus 6. That's now 10 plus 6 plus 11.6. Nah, it's correct. That's the answer I got.